Welcome to STEAM Education Hub. In our last tutorial, we have been looking at speed, velocity, and acceleration. Now, when we talk about speed, we know that speed is a rate of change of distance with time. Velocity is the rate of change of displacement with time. And equally, acceleration is the rate of change in velocity with time taken. Now, I want you to take note of this important point. Speed is a scalar quantity. That is, it has only magnitude but no direction. While velocity is a vector quantity. That is, it has both magnitude and direction. So if acceleration is a change in velocity, it means acceleration is also a vector quantity. Now let's delve into the calculation involving acceleration. Question number 1. A train travels from rest to a velocity of 30 meters per second in 6 seconds. What is its acceleration? I want you to take note of this problem very well. In every problem, we must bring out the given in the problem. Now, let's bring out the given in this problem quickly. The given here is u, which is regarded as our initial velocity. And remember, initial velocity is our starting velocity. So the starting velocity at this point that this train is using is 0 meters per second. That is, the train at this point is at rest. So the initial velocity is 0 meters per second. Then the final velocity here, which is v, is equals to 30 meters per second, and the time taken is 6 seconds. Now let's substitute this given into the formula for acceleration. You know, acceleration A is equals to v minus u over t. So now substituting this, we of course are now going to have 30 minus 0. That is the final velocity minus the initial velocity divided by time, which is what? 6 seconds. Now 30 minus 0, you know, it will still give us 30, and 30 divided by 6 will give us 5 meters per second square. Take note, there is a reason why acceleration is measured in meter per second square. You must take note of this very well. Now, you know, change in velocity is meter per second. Then dividing it by seconds, which is the time taken, we will now have what? Meter per second square. That is why we have 5 meters per second square. Now let's move to the next question. A cyclist accelerates from 10 kilometers per hour to 25 kilometers per hour in 5 seconds. What is the acceleration? Now, I want you to take note of this problem. This is more advanced as compared to number 1 question. Now, what we are going to do here is very simple. I don't want you to be afraid of it. It's still very simple. This conversion, you see how we'll delve into it and you see the clarity. Now, the first thing you ought to do is bring out the given, as we said. Now, the given in this problem, the first given is our initial velocity u. Take note very well. The initial velocity is a starting velocity. And the starting velocity here is 10 kilometers per hour. And if you look at it, now kilo stands for 1000. That is, 1000 meters is equals to 1 kilometer. So that is why we are multiplying this. To convert this, we multiply 10 by 1000. So if we say 10 times 1000, it will give us 10,000. Then the number of seconds in an hour is 3600. Take note. Why? Because we have 60 seconds and 60 minutes. So 60 multiplied by 60 will give us 3600 seconds. And bringing them together, so let's divide it. 10,000 divided by 3,600 will have a result 2.78 meters per second. Let's move into the next given in the problem, which is the final velocity v. Now, final velocity v here is 25 km per hour. Just as we did in the initial velocity, which is the starting velocity, is also applicable to this. So we have 25 multiplied by 1000 meter, which represents 1 kilometer. Then we will have 25,000. Then dividing it by what? 3,600 seconds. We know that 3,600 seconds is the number of seconds in an hour. That is 60 multiplied by 60. And we'll arrive at a result, 6.94 meter per second if we divide 25,000 by 3,600. Now, another given is our time taken, which is 5 seconds. Now, since we have gotten this, since the time is in seconds, we don't need to convert this. So it's automatic. So we are now going to substitute all this given into our acceleration formula. You know, acceleration A is equal to V minus U over T. So if we substitute all this value into the formula for acceleration, we'll have A equals to 6.94, which is the final velocity, minus 2.78, which is the initial velocity, divided by the time taken, which is 5. So 6.94 minus 2.78 will have a result 4.16, and dividing it by 5 will have our final answer to be 0.83 meter per second square. I hope you enjoyed the lesson. You can ask your question, put your question in the comment box, and you can equally invite others, like the video, share. Thank you for watching.